The quantum utility of light. This video will try and explain how light and its interaction with the planetary realm's space travel reacts in the episode. It all starts with a ship journey to Alpha Centauri. Alpha Centauri is 4.3 light-years away from Earth. When we look up into space, we see things from a bright star. Yes, and Alpha Centauri, as it was 4.3 light-years earlier because that's how long it takes light to reach Earth from Aloha Centauri. If we travel in a ship through space to Alpha Centauri traveling backwards through time, when we reach Alpha Centauri 4.3 light-years away, having the ship had traveled backwards in time, Earth clocks will have passed by the same rate as the time on Alpha Centauri. Why? Since we would be traveling backwards through time, no time will have passed. Alpha Centauri 4.3 li away with no time having passed, yet have Earth and Alpha Centauri clocks still tick normally. Point 1. World lines and light cones. In special relativity, every object's path through spacetime, its world line, must always stay inside or on its future light cone unless it is moving faster than light, tachyonic, or you've engineered a spacetime geometry with closed time-like curves ETCs. A world line that leans backward through time, i.e., has negative coordinate time direction in some inertial frame, is outside the light cone. That means superluminal motion or an exotic spacetime metric is required. 2. Proper time can't be identically zero. Even tachyons or Alcubierre-style warp bubbles accumulate proper time along their trajectory because proper time is defined locally in the ship's frame. If you force for the entire trip, you're describing a null geodesical light-like path. A material ship can't ride a null path and still carry mass and crew. In known solutions with CTCs, for example, Gödel universe, Typeler cylinders, wormholes with a time shift, the traveler's proper time is always positive. Only the coordinate time in some external frame can run backward. 3. Synchronization of Earth and Alpha Centauri clocks. Suppose you somehow produce a CTC so that you depart Earth at year Earth frame and arrive at Alpha Centauri at YR Earth frame. In that frame, Earth's clocks show -1 year relative to departure. Alpha Centauri's clocks, assuming conventional Einstein synchronization, also read -1. Why? Because they were initially set to match Earth's time and have been ticking at the same rate. So yes, Earth and Alpha Centauri clocks can stay mutually synchronized while your coordinate arrival time is earlier than departure, but for you the elapsed proper time might be, say, +1 month. It cannot be 0. You have created a causal loop. You can reach Alpha Centauri before you left, send a signal back, and potentially prevent your own departure. Classic grandfather paradox territory. 4. What physics would allow this? 1. Superluminal particles, tachyons, require imaginary rest mass and wreak havoc with quantum field theory.
Contraction layers theory.
2. Exotic metrics, Alcubierre warp drive, traversable wormholes, Krasnikov tubes. All need negative energy stress energy tensors that violate the known energy conditions. 3. Rotating cylinders or cosmic strings, Typeler oven Stockholm cylinders and GOT spacetime can produce CTCs, but demand unrealistic densities or infinite length. 5. Where your scenario conflicts with relativity. The moment you prescribe no time passes on the ship, you eliminate any time-like or even light-like world line for massive matter. If you merely want Earth and Alpha Centauri to perceive no elapsed coordinate time while the ship still experiences positive proper time, you must introduce exotic spacetime engineering plus negative energy. That is already far beyond empirical physics. Take away for C theory, quanta physics. If you want to fold this idea into your speculative frameworks, 1. Decide whether you allow CTCs and which stress energy violations your theory tolerates. 2. Make clear that no external time passes refers to a chosen coordinate frame, while proper time for the traveler remains positive. 3. Address causality. Your theory needs new rules, for example, Novikov's self-consistency, parallel branching to avoid paradox. Referring to relativity theory are other mishaps in Einstein theory. Another, all things relative to Einstein's ideas come to an end at light speed. That was his predicament. The most earliest is his subject about time. Time is an illusory predicament. Referred to reality and the subject about energy, mass, elements, and all things that exist, time in factuality is an illustrious. You can touch it or hold it in an percular way. It's a reflection of a source, as such its secondary illumini. Most equations made in Einstein's theory of relativity are based on his principia about light. Light has no absolute mechanics which make it an element or substrate-based quantum state. It exists, and because of it, things can be observed. Without light, we would exist in a deeper realm of light and/or no spectrumosity at scale. The universe is an ever-expanding equilibrium. A natural quantumosity, or twisting of electromagnetic equilibriumic waves having a constant but accelerating travelocity expansion field, possibly that which physical engages sustainability of the Higgs field. That which permeates mass amongst subatomic energy, both negatively chargeable and positively chargeable equilibrium in nature, masking a positive flow of energies that cancel each other out into a positively flowing vacuum field, but with enough positively charged subatomic particle interaction that allows accelerating the universe into an emerging expanse at a constant Hubble rate, accelerating fluorescently. Obtained negative energy creating a constant flow of pressure. Such a field that permeates a repulsive energy that cancel each other out at a constant rate, allowing plausible equilibrium expansion in the space field.